Video 3.2 explainer, problem 65. A typical laboratory centrifuge rotates at 4,000 rotations per minute. Test tubes have to be placed into a centrifuge very carefully because of the very large acceleration. We have two parts. What is the acceleration at the end of the test tube? That is 10 centimeters from axis of rotation. B, for comparison, what is the magnitude of the acceleration a test tube would experience if dropped from a height of 1 meter and stopped in a 1 millisecond long encounter with the hard floor? Our objectives with part A will be to understand centripetal acceleration, how to convert between units, and the relationship between angular velocity, linear velocity, and centripetal acceleration. And our objectives for the second part will use kinematics to find the magnitude of acceleration and understand how gravity affects objects falling or moving objects in the vertical direction. A, what is the acceleration at the end of a test tube? That is 10 centimeters from the axis of rotation. So there's a couple parts of this. We want to find our velocity, or we want to find our acceleration, which is this. Since we know that the acceleration is constant, we're going to assume that it's constant. It's not changing. So that equation is is velocity squared over r. But since we don't know our velocity, we're going to have to find our angular velocity, which is 2 pi times the radian. And we know, so that's where we're going to have to convert our SI units, because 4,000 rotations per minute doesn't give us our radians. We need to find our radians per second. So we can do this as 1 minute over 60 seconds times 4,000 over 1 minute to cancel out those, which is just going to be 4,000 divided by 60. And you multiply that by 2 pi radians, because 2 pi is the circumference of a circle, the equation for the circumference of a circle, and that gets you 418.9 radians per second. And then the other thing is for our radius, we want to get our question in meters. So we're going to do 1 over 100 centimeters. That looks like 1,000 is supposed to be 100 times 10 centimeters will equal 2.1 meters. So back to this, our centripetal acceleration is going to be our angular velocity here times r, which will end up giving us our linear velocity, which is this vector here, squared over r, which simplifies down to angular velocity squared times r, which is 418.9 squared times 0.1, which gives us this 17,472.4, let me make that more clear, radians per second squared as our acceleration. B, what is the magnitude of the acceleration test tube would experience just before hitting the ground if dropped from 1 meter and stopped at 1 millisecond long encounter with the floor? So we have our height here, 1 meter, and we know our initial acceleration is going to be 9.8, but we want to find the magnitude, so the length of that. And we're going to find this, we want to first find our final velocity. So what's the velocity right before it hits the ground? And we're going to subtract that by, we're going to use our kinematic equation to find using height. So we subtract change in velocity equals 2 times AH times height. We plug G in for A, get the square roots, and it'll be 2 times G times height, 1 meter, square root, and we'll get our final velocity 4.43 meters per second. So we can use this kinematic equation, velocity final is velocity initial times AT, 4.43 equals 0 plus A times 1 millisecond, and we'll get our magnitude of our acceleration is 4.427 meters per second. I think some problems that can come up is not converting our SI units, or trying to find the wrong acceleration, just assuming that the acceleration is just 9.8. So